So it has been a couple of days since the last AWS outage happened, and this was one of the major outages in terms of downtime that AWS had in the recent history. There was a little more than 15 hours of downtime, total downtime. Although the initial problem had been solved within the first few hours, there was a lot of other cascading effects that had to be solved. So what resulted out of this was global outages in key services like accounting software, banking software, messaging software, and also some really stupid services like smart mattresses going down because they couldn't talk to AWS and could not let people sleep on those mattresses. There's apparently estimates of multiple millions or billions of dollars of loss as a direct result of this outage. There's been a lot of opinions and reactions to this outage from different parts of the industry. But I'm here to present a different kind of opinion that says the major part of the fault lies on those service providers that had a major downtime because one region in AWS went down. So before I go into the details, if you are new to the channel, welcome. I'm a cloud architect by trade and I do videos like this on cloud software engineering and other related areas. If you find this helpful, please consider subscribing and like or dislike the video. Put your opinion in the comments. I like those interactions. I like when that feedback comes in. Let's get back to the video. I'm going to talk about 4 major points that I want to discuss about cloud and usage of the cloud. And before I go into those points, I just want to say that I'm not just shilling for the cloud. Of course, there's a financial incentive for me to talk about the cloud. I am a cloud architect. I do think there has to be justification on why your software is on the cloud as opposed to on-premise. But on the other hand, if you are already in the cloud, then you should do things correctly. If you are not engineering correctly on the cloud, that's just bad engineering, that's bad architecture, and also bad risk management. Talking about risk management, the first point I want to talk about here is the fact that there's no such thing as 100% availability when it comes to these cloud services. This is something that should be known from day one if you're considering a move into the cloud, if you're considering building in the cloud. Now, no one actually sells cloud services, no one actually sells migrations into cloud by saying the cloud will be always available. If at any point someone tries to sell you cloud services by saying that one of the positive things about the cloud is that it'll always be available, then run as far as possible from that person because they're not selling you something genuine. There's no way that a cloud service will be 100% available from a given single point of service. What I mean by a point of service is something like a region, a data center, or a collection of data centers. It's almost impossible engineering wise to provide 100% availability from a given single region. But unfortunately, what I found is that people use the term cloud as this single black box of a term that they can hide their complexity behind. They think that as soon as they move their workloads into the cloud, those workloads are going to be 100% available all the time, and they can just forget about architecture, they can just forget about uptime, availability metrics, and all of those things that they would otherwise do when they would host these services on-premise, in on-premise data centers. In the real world, this is not the case. You have to do architecture, you have to design specifically for the cloud. This is why in major migration efforts, you first move into the cloud, maybe just doing lift and shift, and then try to follow that effort up with trying to modernize and make those systems as cloud native as possible, because you need to do actual engineering, you need to do actual architecture designs on the cloud using the cloud services and also using the qualities of the cloud to do better design. To add to this, US East 1 is one of the most volatile regions in AWS service. There's a technical reason for this. It's also the first region that AWS created. If you know anything about software, if you have built software, you know that as the time progresses, there's going to be a lot of technical debt. There's going to be complexity that can't be really solved in a day or two. When AWS builds a new region, like when they built the New Zealand region, they would have a lot of lessons learned that they can apply from day one. But when it comes to older regions like US East 1, there's going to be a lot of technical debt that can't be solved because cloud is a really complex piece of software. You can't really change stuff without affecting a huge part of the internet, like we saw the other day. So if you're operating in the cloud, you should know these details. Of course, these are not the details that the business part of the business will know about, but you have engineers, you have architects. So when they recommend that you don't depend on US East 1, you should probably listen to them. Another part of this point is when major outages like this happens in the cloud, recovery from those events can be really tough. The reason for that is these downstream services like the cloud, like the key network services, when they go down, there's going to be a lot of requests that will be queued up, that will be buffered, waiting for that service to come up. And when these services do actually come up, all those requests will start to demand responses from the service, and it will try to overwhelm the service again. So you have to kind of plan the recovery itself. So if there's going to be a major outage like this, you should expect that there's going to be a couple of hours of downtime. And this point neatly ties to the next point that I want to make about the cloud being a shared responsibility model. Almost everyone who starts learning about the cloud learns about the shared responsibility model from day one. But as they kind of start getting comfortable in the cloud, there seems to be a pattern of forgetting this fact that you have to worry about availability, security, and performance in the cloud rather than all those qualities of the cloud. Let me explain that point a little bit in detail. So when you host a service in the cloud, the uptime of that service is going to depend on two collective efforts. One is the uptime of the cloud, the security of the cloud, the performance, availability, all of those details of the cloud services itself. That part of the responsibility is taken care of by the cloud provider. So in this case, that's going to be AWS. But the availability, security, and performance in the cloud of your system, that's going to be your responsibility. This builds on the earlier fact that I mentioned that nothing's going to be 100% available. So you have to always assume that these core cloud services will go down, and you have to make use of qualities of the cloud like having multiple availability zones, having multiple regions to reach your desired availability numbers. And most cloud engineering efforts starts with high availability and fault tolerance. So this is why I get a little bit pedantic when someone says the cloud is just someone else's computer. That is just half true. It's also a collection of services. It's also the shared responsibility model. It's also how you operate in the cloud as much as how operational the cloud is. So in this case, when a key accounting software service goes down, or when the bank actually goes down, part of that responsibility of course lies with the cloud provider, but a major part of that responsibility had been with those service providers because they were already in the cloud. They knew they were operating in the cloud. They should have expected these services to go down. So this was ultimately a matter of risk management, and that ties neatly to the next point that I want to make. A smart mattress that you bought actually went down because one of the AWS regions went down, right? So of course, why this region went down is a technical problem. It looks like it's an interesting problem. It looks like someone pushed incorrect DNS configuration, and that had a cascading effect that went out to all the other services. But this is not about AWS going down. This is about the businesses that decided, depending on a single region, and having that region going down is an acceptable business loss. So let's say you're an accounting software service provider and you depend on a single region. There are several possibilities here. One is you didn't know that you were depending on a single region. So that's bad technical management, that's bad architecture, and you don't have a lot of visibility into your business capabilities. Two, you did know that you were depending on a single region and you accepted the loss of business from having that region go down as an acceptable business risk. If that was the case, in this instance, you made a bad call. Another possibility is that there were a lot of signals from your organization that said we are depending on a single region, we have this single point of failure, we should design better on the cloud, and you ignored that because someone said the cloud will always be available. So even in that case, you made a bad decision, even if you had good recommendations from your business. This is why I categorize this as a business problem. It's always about risk management and how good the data you have when it comes to either accepting or mitigating certain risks in your technical stack. In the next few weeks, there's going to be an uptick on videos, articles, and opinions about how the cloud is over-engineered and you should start hosting all your services in a VPS or on an on-premise server. If I try to put this as neutral terms as possible, if you think the cloud is over-engineered, you don't have the full picture. You are really underestimating what the cloud can do and what use cases the cloud needs to address. I do think the meaning of the term over-engineering has been diluted a lot. There's obviously a lot of drama in YouTube in these opinions. So if you say the cloud is complex, no one really pays attention. But on the other hand, if you say the cloud is over-engineered, then there's a dramatic effect. So people will start watching the video, they'll have strong opinions and have all these interactions that will result in a good performing video. But having a complex use case is not the same thing as over-engineering. If you say the cloud is over-engineered, you should also say the Linux kernel is over-engineered, the JVM is over-engineered. That's not the case. These are software technical stacks that should cater to a wide variety of use cases, so of course these are going to be complex. But if you think that makes the cloud over-engineered, then you're missing out on the fact that most of the time that complexity is not really exposed to you, and you have a lot of services to use to simplify your architecture, simplify your deployment in the cloud itself. On a related point, it doesn't matter if the cloud is over-engineered or not. You're always going to depend on some kind of over-engineered software in the complete stack when it comes to hosting services. It doesn't matter if it is the cloud, it doesn't matter if it is the undersea cable that connects your country to the rest of the world. You always have to kind of decide which single point of failure you're going to accept. The cloud is just another utility layer that you're going to use to provide a service to your end users. So you'll probably see videos like how to replicate the cloud in a single VPS server or something like that, but most of the time these people miss the point about the cloud, or they intentionally present something that is not true. So probably don't start moving your entire organizational workload to a VPS just because a single YouTube video said so. So those are the key points that I wanted to discuss in this area. Of course, not all the opinions that I saw are invalid. I'm not discarding all of those opinions together. It's just there's a lot of misinformation and there's a lot of misunderstanding on how to use the cloud. There's of course a lot of introspection that has to be done on why AWS went down like this and why that shouldn't take out key parts of the economy with it. And of course, Amazon, the storefront itself, went down because of this outage. There's probably a technical reason for that. Again, I think it's because it's built on a lot of technical debt that can't be really moved around, and also there's key services that you can't really have a multi-region approach with. So for an example, IAM Identity Center, AWS organizations, the console itself, these services in my opinion shouldn't have gone down just because US East 1 went down. There's nothing that I can do about the scalability, availability of the cloud, but what I can do is to expect these services to go down at one point in time and prepare for that, identify which parts of my architecture will be affected by it, and make the business ready for it. So that's it for this video. I hope this was useful. I hope it made you think about how you operate in the cloud. That's it for me. Thank you so much for watching. I'll see you in the next video.